A few weeks ago I saw this video from Nasher where he attempted to play hockey in the third person. I thought the concept was pretty cool, and honestly I would be lying if I didn't thoroughly appreciate the hacked together engineering setup he used to accomplish this task. It got me thinking though, could you actually make a real life third person viewer? Can I improve upon Nasher's setup? Well, I decided to give it a shot. As a bonus, this gave me the perfect opportunity to work and improve upon my Raspberry Pi action camera project that I have severely procrastinated on the past few months. Yeah, it's been a while. By the way, all the tools, parts, and other resources I reference will be linked in the description below. Now to start off, let's analyze Nasher's setup. For a setup, he has a VR headset containing a phone that is playing video streamed live off a GoPro mounted on a selfie stick that is mounted to his back through a backpack. Oh, he also has a second GoPro recording video since the first is streaming video and thus not able to save its own video. Got all that? As you can see though, pretty linear design and nothing too complex, so I tackled each part of the design bit by bit. I decided to start off with the core piece that everything would mount to fit in a very liberal definition of self-contained setup. To do that, I decided to use an old hockey helmet, and to complement this, I decided I would mount the camera on a boom-like assembly to the back of the helmet instead of on my back, so that way my head movements could control where I was looking for increased control in the third-person view. The next step was to decide how I was going to plan to get the camera behind me to give me that third-person-like view of myself. I didn't have a selfie stick on hand, but I did do some digging on Thingiverse and came across this modular design system that supports GoPro-style mounts. I printed up a few of the longer extension arms and was pretty happy with the concept of using these for the boom. Now before I put them all together, I needed the camera to mount at the end of the arm. My initial plan was to use the core design of my Raspberry Pi action camera project, which is essentially just a Raspberry Pi Zero and a V2 camera module modded with a fisheye lens. The one modification I did want to make to this was to move the Pi Zero itself to be on top of the helmet and only the camera would be at the end of the boom arm. I wanted to do this to reduce the weight at the end of the arm and lessen the force at all the joints linking each of the extension pieces together. Now I could have done this by just getting a really long ribbon cable, but ribbon cables are pretty fragile and getting a long one that supports Pi Zero is a bit harder to find. So I use this as an excuse to buy these passive CSI to HDMI converters to try out. These allow me to switch the CSI connection to be carried over a much stronger HDMI cable, and honestly this concept intrigued me. Now these are passive, so the HDMI cable is not carrying an HDMI signal, it's still just a CSI signal over the wires. The two converters cost a total of £17.40, which after fees, shipping, and converting to good old USD, I was just shy of $30 total. The creator of these connectors also has a 3D printable case for the camera end containing the camera and HDMI connector, so after some slight modifications to support my fisheye lens and adding a separate piece to add a GoPro mount to the back of the case, we had all the building blocks for the camera half of this project. So I began assembling the pieces together. The screws for the extensions, which are just M5 bolts and nuts, ended up being extra long because you were meant to also print a hand screwing knob that fit over the top part of the screw. I didn't really want that for every link, so I just got weird extra length on the ends. Oh well. The fisheye camera with 3D printed case were really rough to put together and assemble into the block in the case, but I got it at the end. Not all the screws held tight to the case, so I added some electrical tape around it to hold it all together. With that all being assembled, it was time to test the camera with the Pi and the HDMI connection. The first HDMI cable from Amazon Basics didn't work. According to the creator of the CSI HDMI converter in a blog post, it seems it may be due to the Amazon Basics cable being cheaper and not containing all of the grounds. Either way, I found another HDMI cable lying around that did work and I used that instead. Next, I took a Raspberry still image and boom, it's all working. Next up, I need a solution for real-time streaming of the video from the Pi Zero to a phone. Ideally, this would be something that I would also integrate into my Raspberry Pi action camera system, but we'll see how that goes. I tried a lot of different methods like RTSP, UDP, TCP H.264, raw streaming with Netcat, and GStream, and either I couldn't get the solution working or the delays were in excess of 1 second, which for real-time streams is not low enough. I wanted to speak more to all these methods as most of my time was spent here, but honestly it was just a lot of trial and mostly error. In the end though, what ended up working for me and giving me a workable real-time solution was another project called Raspberry Pi Cam Web Interface. Actually it's RPI Cam Web Interface, but you get the point. Now I can use their solution outright for this project, but I would not be able to use it for my own Raspberry Pi action camera project. But after doing some initial digging, it seems like they're using an underlying tool called RaspberryMJPEG, which is based on Raspberry Still and Raspberry Vid, and something that I could definitely look into incorporating. Anyways, back to this project. Now with video working, time to move on to the VR headset to actually view said video. Now I've never personally used VR, nor do I own a VR headset. So in my spirit of doing this prototype cheaply and DIY friendly, I decided to do the most ultimate DIY prototype VR headset you can do, and that is Google Cardboard. Google Cardboard is an initiative from Google to make VR accessible to everyone, and if you haven't figured it out, it's a design that allows you to make a VR headset out of cardboard. You do need to find/buy lenses for it, but everything else is easy to find at a supply store, or you might even already have in your home. Currently, it seems Google has a new V2 spec of the VR headset, but it appears to be less DIY friendly. Luckily though, I did find a printout of the V1 design that allows you to simply print out the design on paper and use it as a stencil on the cardboard. With that said, it was time to get cutting. I will say this was far from my best work, but honestly it's cardboard and these are not really meant to be that good, just accessible introductory to VR. But for a first prototype, it'll work. Since Google Cardboard doesn't have any mechanism to secure the headset to your head, I decided to 3D print a hinge that will screw onto the front of the helmet and connect to the headset that way. This way I won't have to hold it when I'm actually testing. Now all that's left is to assemble it and try it all out. I printed out a very basic Pi Zero case to put the Pi in and secured the HDMI connector to the top of the case with tape. I also screwed all of the boom arm joints together and mounted them to the helmet. Lastly, I drilled holes into the hinge to mount and mounted it onto the helmet with some makeshift M3 screws since the ones on the helmet were too short. I then glued and taped the headset to the other end of the hinge. And there we go, we have a very jank first prototype. I'd argue just about as jank as Nasher's, but hey, small steps here. So, how to do? Well, for the video I can show you guys honestly pretty well. In this screen recording off the phone I was looking at in the headset, it's actually pretty promising. Obviously the camera's position relative to me needs to be worked on, but it's functional, from what you can see. And in case my demo of me just sitting on the floor in my office doesn't give it away, my perspective of this said video through the Google Cardboard is very rough. I'll try to do my best to simulate to you guys what I saw, but it's just not good enough for me to want to try this outside and test it. So what went wrong? Well, honestly the only thing that really went wrong is the VR headset. There is a reason why Google Cardboard isn't sweeping the nation with this do-it-yourself VR headset. It's just not very good beyond basic introductory experience into VR. Between that and my terrible assembly of this, it just wasn't going to turn out right. The lenses were not correctly placed, it did not fit together very well, and my old Google Pixel 2 XL is way too big for what this is designed for. And to top it all off, I didn't even really do this correctly. I simply just played a video on the screen without any VR adjustments. This means that my eyes are essentially looking at two very different videos since each eye can't see the whole video. This is what led to more of the issues, as essentially I couldn't see straight. Yes, I could have spent more time to try and split the video feed into two for each eye, and I did try a video off YouTube meant for VR like that, and it was much better, but the headset and lenses were still just too imperfect for me to want to go further with this effort. So with all that being said, what improvements could I make if I were to make another prototype of this? Well, the biggest would be to ditch Google Cardboard headset completely for another cheap headset like the Google Daydream. I could pick one off of the Facebook Marketplace for like $20–30 and get a world of difference over my current setup. I would also have to look into splitting the video feed so that both eyes can work together to actually allow me to see the environment around me without this weird split eye mess. Some more aesthetic or not necessarily needed changes I would probably look into doing are making the boom arm better and adjusting the camera position, polishing the Pi and HDMI connector main box that's on top of my head, and then looking into the HDMI cable method and asking, is HDMI really the best solution here? The cable was a bit annoying to deal with, bulky, and not that really easy to shape and conform to my design. So with all that being said though, that was my journey of me making this IRL third-person helmet. Let me guys know if you want me to continue with this project and make a second prototype, but also be sure to keep an eye out for the Raspberry Pi action camera project as I begin working on adding a new audio solution, and will update you guys on my first completed version of that project hopefully soon in the near future. Again, hopefully you guys have enjoyed my recap of my journey here. Thanks all for watching. I'll catch you guys next time. Peace out.